Hello viewers, myself Hasina Bibi, Assistant Professor, CSE Department, Rohini College of Engineering and Technology. In this video lecture, we are going to see on topic Introduction to Functional Programming Languages from the 5th unit for the subject Principles of Programming Languages. Functional Programming Languages. Functional programming languages are specially designed to handle symbolic computation and list processing applications. It is based on mathematical functions. Some of the popular functional programming languages are Lisp, Python, Erlang, Haskell, Clojure, etc. Functional programming languages are categorized into two types. They are pure functional languages and impure functional languages. Pure functional languages are the languages support only the functional paradigms, for example Haskell. Impure functional languages are the languages which support the functional paradigms and imperative style programming, for example Lisp. Functional programming languages are having certain characteristics like they are designed on the concept of mathematical functions that use conditional expressions and recursion to perform computation. It supports higher order functions and lazy evaluation features. They don't support control flows like loop statements and conditional statements like if else and switch statements. They directly use the functions and functional calls. Like OOPS, functional programming languages support popular object oriented and object abstraction concepts. The design of imperative languages is based directly on the von Neumann architecture. The design of the functional languages is based on mathematical functions, a solid theoretical basis that is also closer to the user but relatively unconcerned with the architecture of the machines on which programs will run. Mathematical functions. A mathematical function is a mapping of members of one set called a domain set to another set called the range set. A lambda expression specifies the parameters and the mapping of a function in the following form: f of x, x star x for the cube function, cube of x equal to x star x functions. Lambda expressions are applied to parameters by placing the parameters after the expression. For example, f of x, x star x is the function, and following that there will be the parameter 3. So the parameter 3 will be applied to the variable x, and this as a result of this expression we will get the result 27, that is 3 star 3 star 3. Functional forms. A higher order function or functional form is one that either takes functions as parameters or yields a function as its results, or both. A functional form that takes two functions as parameters and yield a function whose result is a function whose value is the first actual parameter function applied to the result of the application of the second form, that is h of f g, which means h of x f of g of x. Construction. A functional form that takes a list of functions as parameters and yields a list of the results of applying each of its parameter functions to a given parameter. For example, f of x equal to x star x and g of x equal to x plus 3, f comma g of 4 yield 64 comma 7, that is the parameter value is 4 in both of the functions, that is f of x and g of x. The same parameter 4 will be substituted for the variable x, and so for the f of x we will get 64, 4 star 4 star 4 64, and for the g of x we will get 4 plus 3 7. So f comma g, the function of a functional form of f comma g will produce the answer 64 comma 7. Apply to all. A functional form that takes a single function as the parameter and yield a list of values obtained by applying the given function to each element of a list of parameters. For example, h of x equal to x star x. f of h of 3 2 4 yield there are three functions are abstracted in this. For the first form, the parameter is 3. So the entire function h of x will be evaluated by applying the parameter 3. So we will get the value 27. And in the second time, the entire evaluation will be performed by applying the parameter 2. So we will get the value 8. And in the third time, 4 will be substituted for the x and the function will be evaluated and we will get 64. So f of h of 3 comma 2 comma 4, by evaluating this we are getting the value 27 comma 8 comma 64. Lisp. Lisp is the first functional programming language. It contains two forms. Those are data object types and list form. Data object types are originally only atoms and list. List form parenthesized collections of sublist and or atoms. For example, A, B of C, D of C, D, G, E. Fundamentals of functional programming languages. The objective of the design of FPL is to mimic mathematical functions to the greatest extent possible. The process of computation is fundamentally different in FPL than in an imperative language. In an imperative language, the operations are done and the results are stored in a variable for later use. Management of variables is a constant concern and source of complexity for imperative language. In an FPL, variables are not necessary as is the case in mathematics. The evaluation of a function always produces the same result given the same parameters. This is called a referential transparency. Lisp was a type of typeless language. There was only two data types, atom and list. Lists are stored internally as a singly linked list. Lambda notation is used to specify functions and function definitions. Function applications and data all have the same form. If the list A, B, C is interpreted as data, it is a simple list of three atoms A, B, C. So that's all about the topic. Thank you.